everything that we're going to do for the next several weeks and even beyond that, we kind of already know how to do, okay? Or we at least have one version of being able to do it, okay? The idea of mathematics is, can we develop procedures, processes, sometimes called algorithms, that allow us to generate the same result but much quicker, much more efficiently, okay? And that's kind of what today's about, because we already know that if we take, let's say, y equals 2x minus 1, that's the first equation we're going to deal with. If I go y equals 2x minus 1, we already know that we can say, well, x and y are in this table, and I can say x is 0 and get negative 1 back, x is 1, get back 1, x is 2, get back 3. We already know that, right? Okay? And these would be ordered pairs that we could plot. So I can graph 0, negative 1. I could graph 1, 1, and graph 2, 3, right? And we can do that, okay? Now, that wasn't all that of a strenuous process. I could connect those and get a line, but that wasn't all that difficult. And one reason why it wasn't all that difficult is because that equation has really nice values and integer values. But if I had something like y equals, let's say, negative 4/5 x minus 3, okay, and I go x's and y's, and I go 1, or so let's go 0 again, and I get negative 3 back. But now if I go 1, well, now I get negative 4/5 times 1, which is negative 4/5, and now subtract 3 from it, and there's a lot of work there, right? There's a lot of math to get that ordered pair, and that's time-consuming. So hopefully maybe there's another way, another procedure that allows us to do that and get the result, the end graph, much quicker, and that's what today is about. Eventually we're going to come up with several different ways of being able to generate a graph from an equation, and basically the other ways, the other techniques, essentially depend on how the equation is written for us. So right today, we're going to start with the equations written in y equals mx plus b form, okay? So like 2x minus 1, like negative 3x plus 4, something like that, okay? In order to graph, the first thing you're going to do is identify what your slope and y-intercepts are. That's exactly what we've been working on the last day and a half or so, right? Okay, knowing where our slope was and our y-intercept. Step 2 says you're going to plot the y-intercept. That's the first thing you always have to do, plot the y-intercept, okay? And that step is actually analogous or the same as us coming over here and choosing x to be 0 and getting y to be negative 1. Does that make sense? Because that would, if I plotted that, that would be on the y-axis, okay, which is my y-intercept and my line. Step 3 then says from the y-intercept, you're going to apply the slope, which we're going to refer to as our rise over run, or look at it as our rise over run, and plot a second point, okay? Now, the number one error that people make when graphing lines and not getting the correct line, the correct visual representation of the equation, is when they get confused on what we're doing. When we graph just a list of ordered pairs, right? If I give you let's go those 3 ordered pairs up there, 0, negative 1, 1, 1, and 2, 3. If I ask you to graph those, when you graph each one of them, don't you start at 0, 0, and then move left and right, and then up and down? Okay? And then you go to the next one, you start back at 0, 0, and move right 1 and up 1. Okay? And you put a point. And then you go to the next one, you start back at 0, 0, and you go to the right 2 and up 3. And you get 3 individual points that were all referenced off of 0, 0. They all started at 0, 0 when you were trying to find them. When we apply our rise over run, your rise over run is always going to be applied off of the last point you came up with, okay? The last point that you came up with. So in step number 3 there, when it says from the y-intercept's location, apply the slope or rise over run, and plot a second point, you always do that from your y-intercept, okay? Step 4 says repeat step 3 from previous point as many times as necessary. How many points do you need to make a line? 2. So step 2 and step 3 actually will always be enough, okay? But I want to give you kind of a visual here in a moment of why maybe step 4 is kind of important to us occasionally. Not always important, not Not a 100% have to do that every single time, but we'll talk about it. And number 5 then says connect a series of points with a line. Lines are things that by a geometric definition, a line is a series of points that extend in both directions forever. They never bend, they never curve, they never break, there's no gaps in them, nothing like that. So when we draw our line, we have to put arrows on the end of it to tell everybody that it is going on forever. Okay. Some of the graphical things that we do in this class, and if we grasp them, like procedures like that, will make geometry, the introduction of geometry next year for you a little bit easier. Why do we want to graph maybe more than 2 points? Here's just kind of an example of a situation I think is important for us to see why maybe we might need 2 points or more than 2 points. If I've got, let's say this, I'm gonna make that a sheet of drywall. You guys know what drywall is? Okay. And drywall comes in panels of 4 feet by 8 feet. Okay. Let's say I'm drywalling my ceiling at home or whatever, and I got the last piece to put up, and the last piece to put up only needs to be 3 feet by 8 feet. So I've got to cut a foot off of this side, right? Okay. So what I'm going to do, and this is hopefully this makes sense, is you're going to put your tape measure right here, right? And you're going to trace down to 3 feet. And you're going to put a mark right there, right? Okay. So that was 3 feet, and put a mark right there. Okay. Then you're going to go, you need how many points do you need to make a line? 2. So right now I don't have the ability to take my straight edge and line it up with anything. Because that's what I'm going to try to do. I'm trying to make either I'm using a chalk line or maybe I've got a long level that I can use as a straight edge, but I don't have anything else to line this up with. Okay. So I need another point. And the idea is if my other point doesn't have enough distance between it and the current point, I'm going to incorporate some human error. And what I mean by that is if I come here and I draw down 3 feet and I put my other point, okay, so I got that mark and I got that mark, okay. If I put my straight edge, now you guys can see kind of the blue lines on the screen here. That's kind of the line that I want or I would want to cut on. Does that make sense? But if I put my straight edge here, do you see how I can maybe make that line or maybe that line because of the human error of that line? That my straight edge is going through those points, right? Okay. But I can maybe get that there's going to be error in what is the actual line I'm looking for. And if I do that, if I draw that line right there, okay, yeah, there's going to be 3 feet here, but it's going to be like maybe 3.5 feet over here. It's not going to fit in that spot that I've got in my ceiling. Does that make sense? Okay. So how do I eliminate that human error? What are most people? What are they going to do instead of putting that second point right there? We usually come down here. We put our second point right there. Does that kind of make sense? And what that does is it puts a gap, a sizable distance between my 2 points, and that eliminates then the potential of having multiple different lines that are going through it. Okay. What most people even do, and contractors will do this a lot, is that they will come in the middle and they'll make a third one. Because now if my straight edge matches up all 3 points, I'm guaranteed that I know the line I'm drawing is the line that I want. Does that make sense? We okay with that idea? So when we're in our problems and graphing here, let's say we do y equals 2x minus 1, and we graph it. Let's say I graph a point like right there. Okay? And then I graph my next point, and it's like right there. Those 2 points are so close together that I'm going to have problems drawing the accurate line that I really need. Okay, now this becomes a big issue when we're going to use this line later on in the year and maybe in a science class to predict something in the future, to predict what my y value is when x is beyond 10 on my graph here. Okay, so what I want us to do is make sure that we don't use just 2 points like that. If my points come up and end up being very close together like that, I'm going to try to make 3, 4, 5, 6 of them and line them all up with a line that way. Okay? So we're going to practice that, and hopefully that concept will make sense as we start seeing examples of this. So as we go through these examples, okay, the number one thing that we're going to do is try to figure out what the slope is and then what your y-intercept is. Those are your sets of directions on how to graph a line. So when I look at this one, what is my slope? 2. Slope is 2. Now, what is my y-intercept? Y-intercept is -1. Okay? So we worked on that the last couple of days, kind of picking those values off. Now, the number one thing that I think is important for us to recognize is that slope, what is the phrase that we use for slope? Rise over run, right? So right now, do you see this as a fraction? Right now, all you're seeing is the rise, correct? What is the run for that? 1. When your slope is just an integer, remind yourself that it's over 1, okay? And that's one of the errors that people make commonly, is that they'll plot their y-intercept and then they'll go up 2 and then not know what to do from there, okay? So once we have that information, we're going to go through those steps that said plot your y-intercept. Well, my y-intercept, remember your y-intercept as an ordered pair, always has to be on the y-axis, so the x-coordinate would be 0, and the y-coordinate would be -1. Now, you don't need to write that, but when I say y-intercept equals -1, I'm ultimately talking about that ordered pair. So I'm going to go to my y-axis, and I'm going to plot that point at -1. Is that all right? Okay. Once I plot that point, I'm now going to grab my slope. Your slope was a rise of 2 and a run of 1, right? So you always go from the last point you just plotted, and you're going to go up 2, you rise 2, and then you run 1. And that gets you a second point. Okay? Now, you don't have to draw those red segments that I put in there. Okay? And a lot of times you won't. But I want you to see the up 2 over 1 kind of idea. Does that make sense? I think my slope, I view my slope as kind of stair steps. Because if I put a couple of these in there, I can go up 2 more, over 1 more. Does it start looking like I made stairs? Okay. And that's the idea, is that I want to make sure that I get enough of them. Okay, 3 or 4 or whatever, so that when I line them up, okay, because I got 4 over here, I know that the line that I create, when I put my ruler or whatever, and it should be a solid line, it's kind of hard to draw with this tablet, that's the line I'm looking for, okay? I'm going to put an arrow on the end of it to tell everybody that that thing is going to continue going in that direction, showing that behavior for all of eternity, forever. Okay? Now, here's my question. Do you think, if you were like walking on this line and you're starting right here up here in the first quadrant, and you start walking this direction, can you keep going this way? Down here to where we don't have a graph? Let's talk about how we get that stuff down there graph. Okay? Your slope was positive 2 over 1, right? Your slope was positive 2 over 1. Because a positive number is a positive divided by a positive, right? What can I divide? What 2 things can I divide and still get a positive number back? Okay, well, that's what I've got. I've got 2 positive numbers. So don't 2 negative numbers also give me a positive through division? So -2 divided by -1. Okay. Now, usually, if we were trying to write an answer or something, we usually wouldn't write it as -2 over -1, right? We would simplify it and write it as positive 2. But in application of slope, this is going to be useful because now I know that is equivalent to a rise over run of up 2 over 1. So up 2 to the right 1 is identical to down 2, left 1. Does that make sense? Now your rise, like I said, is down 2 and left 1. Okay? And then from that point, I can go down 2, left 1. Down 2 more, left 1. And does that then kind of show the continuation of that line in that direction? Does that make sense, everybody? Now, when I do these, okay, I usually look for 3 points. Okay, I'm not saying that you have to do it the way I do it, but what I do is I always graph my y-intercept first. Obviously, everybody's going to do that first. Okay, and then everybody's going to graph the slope the way it is. So go up 2 over 1 to get that point there. And then what I always do is I go, okay, well, let's just take the negation of both the numerator and denominator of the slope and get that point right there, down 2, left 1. Does that make sense? Okay, so I get that point, and that point, and I think that's usually enough to make sure that I don't have any error in my line, and it guarantees that I've got 3 points that I can use to line up with my straight edge. Now, here's my question. Let's go back to earlier when we were using this chart. I said X and Y, and I said X was 0. You told me when you evaluate that, when X is 0, you get -1 back, right? Is that point right there 0, -1? When you plugged 1 in, you got 1 back. Is that point right there 1, 1? When you plug 2 in, you get 3 back. Is that point right there 2, 3? Does that kind of make sense, everybody? Okay, so our line is a visual representation of that T-chart of X's and Y's. Okay, but the line is a little bit better because the line actually shows us an infinite number of X's and Y's, right? Because that point right there, even though it's not I haven't put a circle on that point where my finger is, there's a point that is probably 1.5, 2. Does that make sense? Okay. This is a visual representation of an infinite number of points. Y equals 2x minus 1 is a rule that allows us to generate that infinite number of points, whether through a graph like this or through that table of X's and Y's. Does that kind of make sense? You guys kind of see the comparison or the crossover from what we already know how to do and what we're now learning? Okay. So let's go over here to this next one. And again, we have to identify the slope and the y-intercept. So what's your slope on this one going to be? -3. Now what should I put that over? Over 1. And now your y-intercept is 4. Okay. So what are you going to plot first? You're going to go up on the y-axis, and we're going to put a dot at 4, so point at 4. Okay. You don't have to right now, but I like to put my ordered pairs like in the graph. Eventually, in other sections, other courses, you're going to be using this graph for something else, and it'd be nice to be able to quickly pull off points from that graph. Okay, so what do I do from there then? Okay, so I'm going to go down 3. So it puts me there. And now when I say over 1, which direction, right or left? Okay, right 1. And it's going to put a point right there, correct? Okay. I think there's a good gap between those. Okay, and so that is the bare minimum I need to create a line. But if I want to keep going, down 3, over 1. And I like to do this especially if I don't have like a straight edge, like the tools that I have right now on my computer, I don't have the ability to like lay a ruler on this and draw. Okay, so I like to get as many points as I can because then I can kind of sketch through there and keep that as straight as possible using just freehand techniques. Okay, now instead of going down 3, and right 1. Okay, when I have a slope right here of negative 3 over 1, haven't we talked about this idea that negative 3 over 1 is the same thing as that where I have that negative out in front? Does that make sense? You guys remember seeing that early on? And when I say early on, that's like 3rd grade. That's when you start talking about fractions, a lot of times they write the negative kind of in line with your division bar. Okay? I always like to put it up in top like this, but there's nothing wrong with putting it actually in the bottom like that. So negative 3 over 1 is the same thing as 3 over negative 1, correct? Much like positive 2 is the same thing as negative 2 over negative 1, right? Okay, so if I switch the signs in my slope, switch the sign in the numerator and switch the sign in the denominator, I now have a series of directions that can take me in the opposite pathway. So instead of going down 3, right 1, can I go up 3, left 1, and put a point? Does that make sense? And then up 3, left 1, put that point, and then I can continue that through with that line. Does that make sense on how to do that? Okay, now I'm going to come down. I want to kind of prove a point. I think do you guys get the idea? Do we need to do one more like this? Let me do this. Let's change this 3 to a 10. Change that 3 to a 10 right there. So if I have that, what's your y-intercept? 10, so that's the first point you plot, right? Okay, a point there at 0, 10. The next thing you're going to do is you're going to apply your slope. What's your slope? Up 2 and then right 3, correct? Now, here's where I want us to make sure we're paying attention. Because you have the physical graph in front of you on paper and pen, okay, you have the ability to extend your y-axis a little bit and just kind of say, okay, well, that distance, like this would be like 11 there, right? And then that maybe would be 12. Can I then go up to the right 3 and kind of guesstimate that that's where that point would be? Does that make sense? So you have that capability if you're drawing on the paper in front of you, and I don't have an issue with that. Here's where we come into having a problem. Let's say we're on Math Excel, or we're on the end of course exam, and that test has a graph like this, and you can't augment the graph. You can't change the graph. You can't add to it. You can't remove from it, whatever. So I can't go up 2 and over 3 because I run out of graph, right? Does that make sense? Okay. So on a test, Math Excel, end of course exam, whatever, you are restrained or restricted inside what I had there as red. You cannot change that. Does that make sense? Okay. So if I don't have the ability to go up 2 and right 3 because I'm off the image, what should I do then? Okay, so I'm going to go, so up 2, right 3 is equivalent to down 2, left 3, right? Does that make sense, everybody? That's still, that division right there is still positive 2/3. So then I'll go down 2 and left 3. So now that gets a point right there, correct? Now that does, when I kind of estimated, that does put it in line with that point right there that I estimated. Okay? But this one, there's no estimation. I know I'm guaranteed that point should be right there. And I can keep doing that. Down 2, left 3, down 2, left 3. Yeah, so if you run out of graph room on your Math Excel or end of course test, that's what you have to do. Now the end of course test, understands that and knows that some people don't realize that you can make this change to your slope. So they will start a question on purpose to where you can't use the slope directly and you have to change the signs of it. Okay? But what I want you guys to understand is when I graph that line, the idea is no matter where you start now, let's say I want to go like right there. I'll zoom in on that blue point. Let's say I start on that blue point. If I go up 2, it would put me right there, correct? If I go over, so going over 1 would put me like right there. Does that make sense? Going over 2 would put me like right there. Going over 3, does it make sense? It puts me right there back on my line. Okay, so the rise over run of 2 over 3 should still be existing on my graph no matter what 2 points I look at. Okay, is that okay with everybody? One thing to pay attention to, and I said this in the last class, so I'll make sure I say it to you guys. From any one of these points to another point, I'm going to go up to the right 3. So I'm always traveling by a vertical line and a horizontal line. Does that make sense? That's how slope is done. Well, if you have a vertical line intersecting a horizontal line, does anybody know what kind of angle is right here always? You guys know what that symbol means? It's a right angle. It's 90 degrees. Okay? If I wanted to travel from maybe this point to that point, I would go this direction. That vertical line and that horizontal line. And that would be a right angle there, right? Okay, well, this is a horizontal line, and that's a vertical line as well, so that would be a right angle there, and that would be a right angle there. What shape is that thing right there? A rectangle, okay? So when we talk about graphing things in the XY plane like we are, a lot of times they call them rectangular coordinates, okay, or a rectangular graph. And the reason for that is because when we move throughout it from one position to the next, we can only move along horizontal and vertical lines. So our movements are in perpendicular relationship to one another, and it creates rectangles. Does that make sense? There are different types of coordinate systems, okay? You ever look at an atlas? You guys know what an atlas is? Got maps in it, right? Okay, and it's got a bunch of grid lines, okay? Latitudes and longitudes, right? Okay? That's a rectangular system, okay, because you're moving left and right, up and down. There are situations where we can move in a circular motion. Those are called polar coordinates, which is something you'll learn later on in a different course. But the number one system that you guys know how to graph things in is often referred to as a rectangular system. Okay. All right. Questions so far? Okay with that? Let's look at this one here, because they'll do about 4 or 5 of those in a row, just like what we just did, and you're going to get in a habit of saying, oh, I know, first thing was M, second thing was B. And is that the case in this one? No. Okay, what is M in this one? Okay, M is -3, and B is 7. Okay. One thing, and I think I might have said this yesterday, and I want to amend it a little bit. I said yesterday that your slope is always the number in front of x, right? It's always the coefficient of x. I want to adjust that a little bit. It is only the slope if y is solved for. If you have one y over here by itself, that number in front of x is always your slope. That's the only case. And why do I say that? Look at this question over here. What's the number in front of x? 4. 4 is not the slope of this line. Does that make sense? And it's because that y is not by itself. Okay? Yes. And so we'll do that example. But if I wanted to graph this, where do I go first? Okay, so go up to 7. And then from there, where am I going to go? Down 3, so 1, 2, 3, and then right 1. and then down 3 more, right 1. Or could I have gone up 3, left 1? Okay. And obviously then connect them. So if I just connect them like that, I've just drawn a segment. Does that make sense? Okay. And our idea, our goal is to be able, why we want a graph here, is to say, okay, well, what if x was 5? What's the y value that goes with it? If I draw it this way, I'm saying that there is no y value that goes with an x of 5. So what I need to do is I need to make sure that I extend it using my line. And now if I say my x value is 5, the y value that goes with it is -7. That kind of makes sense? Okay. And I think that's actually -8. I think I got some error there. I'll put 5 in here. 7 minus 15 would be -8. We okay with that? All right, let's do the next one. We need, and this is where chapter 2 comes into play. We can't graph this. This is not in a y equals mx plus b form yet. So I'm going to put a box around that. I want to get that by itself. 2y by itself. So what do I need to do to get 2y by itself? I could divide by 2. I think it's going to be safer, though, with other problems that we do. How do I get this thing to that side? Subtract. So I'm going to go 2y equals -4x. Now, you could have divided by 2. That's fine. But I think isolating this is kind of a safer thing first. And now, in y equals mx plus b form, the coefficient in front of y is a 1, right? Right now, our coefficient is 2. So how do I make that a 1? Now is where I'm going to divide by 2. So divide everything by 2, and I'll get that, right? Okay. Is there a... Sorry. Is there a plus anything over here after this? No, nothing written there, right? Does that mean I could do that? Is y equals -2x the same thing as y equals -2x plus 0? Now, why would I do that? Why would I maybe think about writing it that way, at least in this first example? So I know my y-intercept. That right there is matching up to the b. Okay? So my y-intercept is 0. So that's the point, it's the origin in this case, right? When your y-intercept is 0, it's the origin. So that's kind of a unique thing. That means that your y-intercept and your x-intercept are the exact same point. Okay? We're going to spend a little bit of time. We skipped section 5.2 in this chapter. We're going to go back to that here in a little bit, probably maybe Friday, and talk a little bit about this type of. This is called a direct variation equation. We'll talk about that again later. But y equals -2x, when you have no y-intercept, your y-intercept is 0. So now from there, where can I go? Down 2 and then right 1. And we'll keep doing that a couple times. Okay. Now here's my question. I think this is important to think about. Is down 2, right 1 the same thing as, what if I multiplied this by 3 over 3? That'd be -6 to the right 3, right? What happens if I go from my y-intercept? What happens if I go down 6 and then to the right 3? Do I get back on my line? Yeah. Because what does this reduce to? It reduces to 2 over 1, right? -2 over 1. So when we talk about slopes, guys, we like to talk about them as a reduced value. But if I have -6/3, or if I had -12/6 or -24/12, those are all equivalent slopes to -2, and they're going to be tools that I could use to graph the exact same line. That make sense? All right. So then we can connect those, make our line, all that kind of stuff. All right. So let's think about this. If you were Jaden, if you're driving, you drive yet? No? If you were a driver, you got your license or your temps or anything yet?
I do.
Huh?
I myself on phone.
Okay. So, you ever drive backwards? Why not?
Maneuverability.
If you drive backwards, let's say I drive to school backwards. I live about 5 miles away. If I drove here backwards and I didn't hit anything, no accidents, no tickets, no citations, nothing. Made it here. I think I'd probably get a ticket if the cops saw me driving backwards. Okay? But if I were to do that safely, would you make the argument that I'm a pretty good driver going forwards?
Yeah. No.
If I could do something in reverse, I could probably be pretty good at doing it in forwards, right? Okay? So here's what I'm going to say. In mathematics, we do that a lot. We learn a process. You took the equation and came up with the graph, right? And if you can do that, okay, the hope is you can now take the graph and come up with the equation. Do it backwards. Does that make sense? If you can do it backwards, you usually demonstrate that you can do it forwards really well. So if I can go take my driver's test for my temps, try this when you go. And when that person sits down in your passenger seat, she'll be a mean lady, and just drive the whole thing backwards and see what she says. See if you pass.
I did my temps this month in January.
Do it. Try it.
Wait, you don't
I
take
meant
test.
20th. They do.
Well, once you get to get your license is what I mean. So I've got your graph here. I want you guys to write the equation. Okay? So what are the things I need to write an equation for? I need the slope and y-intercept, right? Now this picture is not on your paper, but what is the y-intercept here? B is 2, right? Okay? Now if B is 2, now the next part is to find my slope. To find your slope, you can go from any 2 points you want. But what I want to do is I want to make sure that the points I go from are kind of at those corner spots. Does that make sense? So is this at a corner spot right there? My y-intercept's at a corner spot, right? These gray minor grid lines. And then I want to go up. How many do I have to go up? And then over to get back on my line. Up 1, over 2, right? Would that be the same thing as going from like right here to maybe like right there? Let's say I go up 1, 2, 3, and then over 1, 2, 3, 4, 5, 6, right? Up 3, over 6. What is the rise over run of this thing? 1/2. Either way I look at it, right? Either it's 3 over 6, which reduces to 1/2, or 1 over 2. Or I could go over here, it'd be 6. I go from this one to like 1 over here, it'd be 6 over 12. Okay? But now that I've got that, can I go ahead and say that the equation of this blue line had to be 1/2 x plus 2? And that's doing that process in reverse. You can do it in reverse, and hopefully the idea is that you can do it forwards. We cool with that? All right, so the 5-3 assignment, guys, it's been on Math Excel for a while. It did shut off this morning at some point. It is back open. It's going to be due in its totality tomorrow night. Okay, so you got until then to do it. I also went through and I gave, if you've been working on it and trying to graph these things on your own without the learning of it, and you've missed some, I went through and gave 2 similar exercises on all of them. So you can go back if you've exhausted all of your options. There's 2 more available to you, so you can fix those.
Wait, did you unsubmit it? Because when I tried to go on mine, it says already.
Yeah, so on homeworks, when the due date hits, it automatically submits it. But then when I change that due date, it opens it back up to you and it allows you to change it.